Now, as the object is thrown with an angle theta with the horizontal like this, is there any influence on this object? We have to study that. So this is our x-axis, this is our y-axis. Is there any influence on this body along y-axis? I am discussing first y-axis in this direction. Means, is there any external force acting on this body in this y direction? Yes, you are right. Gravity. In lower standards you have studied that about gravity and the gravitational force. You have studied in the chapter types of forces or our classification of forces. You have studied about the gravity and gravitational force, and about Newton you have studied. So recollect that, and then now come here. When the body is moving like this along y-axis, gravitational force acts on this body. That's why it has some influence in this direction, and acceleration due to gravity acts on it. G acts in this direction. And what about the x direction? Is there any force acting along x direction? If the body is moving like this, is there anyone who is applying some force in this direction or in this direction? Yes. If there is some wind, definitely it may oppose, or if the wind is blowing in this direction, it may accelerate it in this direction. But here we are considering an imaginary case in which we are neglecting the effect of wind. Okay, we are ignoring the effect of wind. This is a hypothetical situation. So in this direction we are ignoring the wind because it is little bit complicatory if I include the wind here itself. About the wind and its objection we will discuss in fluid mechanics. So till then I am ignoring that no wind is acting on it, means no one is applying force on this in this direction. As nobody is applying force on it in this direction, the net force acting on this in this direction is 0, and hence the net acceleration acting along the x-axis is 0. So I say that acceleration acting along x-axis equal to 0 throughout the journey. Acceleration acting along y-axis is equal to how much? Z throughout the journey. Now tell me, what is the acceleration acting on this body at this moment? Z only. The body is here. What is the acceleration acting on it? Yes, Z only. What is the acceleration acting on it when it is here? Yes, you are right, Z only. What is the acceleration of on the body along x-axis at this position? 0. At this position, what is the acceleration acting along x-axis? 0. What is the acceleration acting on the object in this direction? 0. After some time the body may be here. After some time the body may be here. What is the acceleration acting on the body along x-axis? 0. What is the acceleration acting along the x-axis? 0. What is the acceleration acting on this body along y-axis? Z. What is the acceleration acting on this body along y-axis? Z. What is the acceleration acting on this body at this point along y-axis? Z. So the acceleration acting on this body is always Z. The acceleration acting along the x direction is always 0 throughout the motion. What happens if the acceleration is 0? We have studied in the earlier case. What happens if the acceleration acting on a body is 0? Yes, it moves with uniform velocity. Means its velocity along x-axis remains constant. What about the velocity along y-axis? What about the velocity along y-axis? Changes. How? The moment when it is moving in this direction, the velocity gradually decreases. As we have studied in case of an object thrown vertically upwards, the moment when it goes along y-axis, at certain height its velocity becomes 0, and then it returns to the earth. The moment when it returns to the earth, its velocity gradually increases. So when it is coming in this direction, its velocity gradually increases. When it is moving like this, its velocity gradually decreases. Here also the same. The moment when it is moving like this, its velocity gradually decreases, and the moment when it starts coming down, its velocity gradually increases. But always the velocity along x-axis remains constant. Now, what is the velocity along x-axis? That is our, here we have measured the angle with theta. These are adjacent component, that is equal to u cos theta, and this is equal to how much? Uy equal to u sin theta. Now here our study is how this u cos theta change, how this u sin theta change. So now let us study its motion along x-axis first. Displacement along x-axis. What is the displacement along x-axis? What is the formula for displacement along x-axis? S is equal to ut plus half at square I am going to take. So as the displacement is along x-axis, I am going to write a suffix like x, here also x, here also x. Do I need to write suffix x here for time? Foolish question. As time has no direction, we can't split the time along x-axis and y-axis. Can you say that what is the time along x-axis? What is the time along y-axis? Is it right question? Stupid question. That's why we need not write x here. X to t square. Now, if I assume that the displacement along x-axis sx is equal to, I am going to write x. What is my ux? Ux equal to u cos theta. U cos theta into t plus half. What is my x? Acceleration along x-axis we have studied. Acceleration along x-axis equal to how much? 0 into t square. That implies x is equal to how much? U cos theta into t. Hence I can write that t is equal to x by u cos theta. Remember this. What is that? T equal to x by u cos theta. Now in this time interval, how far it travelled along y-axis we are going to study. We are studying the same. In this time interval, what is its displacement along y-axis? Displacement along y-axis. How much? Same formula. S is equal to ut plus half at square. But as I am discussing along y-axis, I am studying the motion along y-axis, I am going to write a suffix here, y. Do you need to write y for t also? No, as you know. So what is our sy? The motion along y-axis, that's why I am going to write it with y. So here maybe the object is at some time t, this is displacement along x-axis, these are displacement along y-axis, y, that's why I am going to write here. What is our uy? Y equal to u sin theta, the motion along y-axis is equal to how much? U sin theta into t plus half. Here by acceleration along y-axis equal to how much? G into t square. As you know already, here I have to apply the sign convention. Here the displacement is along upward direction, so y is in the upward direction. Ux or uy, initial velocity, is also in the upward direction. Acceleration a equal to g, which is in the downward direction. As it is sign convention, it is our convenient, we can choose as we wish. If I take this as plus, this as plus, this should be minus. If I take this as minus, this as minus, this will be plus. So I am going to take this as upwards plus, this minus. Or I can take this is minus, this plus. Whatever the combination you take, you will get the same answer. So I am going to opt this because each author is following this, I am also following this, no other reason. So y equal to, if you wish, you try with this sign, you will get the same answer. Try it. Y equal to, y is plus u sin theta, uy is plus into t minus half g into t square. As g is minus, I wrote minus here. Now I would like to replace this t with this. So I can keep the t here and I keep the same t here also, and let us see what happens. Take a white paper, and I hope you are maintaining in white bound notes for me. Note down this. I don't want to wait till you write. I will continue. So when you are writing, just click on the pause button. I still like this. You write this. So click on pause and write down. Once you finish, click on resume. My video continue. Yeah. See, y equal to u sin theta into, instead of t, I can write x by u cos theta minus half g into t square, means x square by u square cos square theta. Y equal to u gets cancelled, sin theta by cos theta, yeah, you're right, tan theta into x minus half g x square by u square cos square theta. We have arrived one equation, very beautiful equation. What does it infer? Let's see now. Here, what is this theta? Theta is the angle of projection. Angle of projection means the angle with which you have projected it, you have thrown it. Is it constant or variable? Yes, it's constant. If I say that I have thrown this ball with 45 degrees, with what velocity I have thrown it? 45 degrees. With what velocity I have thrown it? 45 degrees. After some time I will ask you. Yeah, my dear students, with what velocity I have thrown that stone? Yes, 45 degrees. Always 45 degrees. That's why theta is constant. If theta is constant, tan theta is also constant. So I am going to replace this constant with some fixed quantity A. Very easy constant. What about G? As you know, at a particular place, here I am doing this experiment, I am speaking about this location only. At this particular place, G constant, u square. What is u? Initial velocity. I have thrown this object with 10 meter per second. With what velocity I have thrown it? 10 meter per second. After some time its velocity may be changed. That is a different issue. But what is my initial velocity? 10 meter per second constant, 10 meter per second constant, 10 meter, always 10 meter per second. If I throw the stone again with some 20, then it differs. But in one experiment, I have thrown this object with 10 meter per second. So with what velocity I have thrown it? 10 meter per second. That's why this u remains constant. As we have discussed just now, theta is constant. That's why cos theta also constant. Means this everything is constant. I am going to write this everything as some fixed quantity b. Now what is this? Y is equal to ax minus bx square. Or some people consider this minus also, and they feel that this everything is minus, then this becomes a plus, where b equal to minus half g by 2 minus half by gu square cos square theta. If I write like this, then b equal to plus half g by u square cos square theta. So both are same. So even if I write like y equal to ax plus bx square or y equal to ax minus b square, it doesn't matter. What does this infer? This infers that this equation represents a parabola. Kya bola? Parabola. Means this says that the path of an object or the path of a projectile is parabola. When an object is thrown like this, have you observed the motion of a ball? If you throw the ball, how does it move? It moves. It will never move like this. It will never go beyond. If you throw the stone like this, see, it rises and it falls. Yeah, it is moving like this. It moves like this. It moves like this. It moves like this. That's why its velocity component along x-axis remains constant, y-axis gradually decreases and then increases. That's why it is falling down. As its velocity is gradually decreasing, it has some inclined slope. It is a curve. It is a curve. Why? its velocity gradually decreasing. If the velocity remains constant, it may move like this. But have you ever seen in such case? If you throw out the object like this, it will definitely fall like this. That is called as our parabola. So hence we can say that the path of a projectile is parabola. So in the next lecture, we are going to study what maximum height the object can reach, what maximum horizontal displacement it can make, what is the time taken by the object to reach maximum height, what is the time taken to reach the ground, what is its velocity at an instant of time. So these are we are going to study in our next lecture. Today you practice this. You may have a book in your hand, otherwise you can find this book, this concept in our ebooks button. Click on the ebooks and go through our synopsis. I hope you wrote my notes also. Revise that and come to my class tomorrow. See you all.